Section 11.3, Inverse Matrices and Matrix Equations, Part 1. In this section, we're going to start out with identifying what an identity matrix is. An identity matrix is noted as I sub n. With an identity matrices are square matrices. You only need one number to describe their size. So if we're looking at, for example, I2, that would mean 2 rows, 2 columns, 1, 0, 0, 1. If we're looking at I3, that would be 3 rows, 3 columns, 1, 0, 0, 0, 1, 0, 0, 0, 1. 3, 2, those are the sizes. 2 by 2, 3 by 3, 4 by 4, 5 by 5, whatever we need. The identity matrix is a square matrix. The main diagonal is 1, and so that's what we see here. The main diagonal is 1, zeros above and below that main diagonal. Main diagonal is 1, zeros above and below that main diagonal. When we look at the identity matrix acts like 1 when we multiply. Okay, so let's look at that example. Let's look at it acts like 1 when we're multiplying. Okay, so we're going to put the identity and matrix G in our calculator. Every once in a while, if I've been doing too much stuff, I might go into memory, option 2, memory management and delete. Option 5 is the matrices. If I have a bunch of matrices in there, I might go ahead and delete them all out just to kind of start fresh. Not necessary, but every once in a while I like to do that. Okay, so second matrix edit. If we look at G, G is a 3 by 3 matrix. So matrix edit, 3 by 3. Okay, so then we put in our entries, 5, negative, 3, 10, 6, 1, 0, and negative 5, 2, 2. Okay, so there's matrix G, or we'll call it matrix A. I'm going to say second matrix edit. Let's go ahead and put in I3. I3 is the identity matrix. 3 means 3 rows, 3 columns. 1's along that diagonal, 0's above and below. Okay, so we're going to put that in matrix B. Second matrix edit. We're going to go into matrix B, another 3 by 3, and then we have 1, 0, 0, 0, 1. Okay, so we have that 1 along the diagonal. Okay, so the identity matrix acts like 1 in matrix multiplication. If we were to take matrix A and multiply it by matrix B, we should get matrix A back. 1 times matrix A would be matrix A. Okay, so let's see if that's what happens. Second matrix A times second matrix B. And notice we get G back. The identity is working like 1 when we multiply. G times 1 would give us G. Okay, so that's a couple of the properties of the identity matrix is it's square, so I only need to know one dimension, 2 by 2, 3 by 3, 4 by 4. The main diagonal entry is 1, 0 is everywhere else. So for example, this would be I3. If I take the identity matrix and multiply it by any other matrix, I get that matrix back. That's properties of the identity matrix. Inverse matrices. Let's look at what inverse matrices are. When I take A and I multiply by its inverse, that should undo the matrix. Okay, what it's going to undo itself to is I. So if I take A and I multiply it by its inverse, or I take the inverse and multiply by A, I'm going to get the identity. If this happens, then I can say these two are inverses of one another. If this is A and this is A inverse, when I multiply them together and get the identity, then I can call these two inverse matrices. If this is A and this is A inverse and I multiply them together, when I multiply them together, if I get the identity matrix, then I can say those two matrices are inverses of one another. Calculate the products of AB and BA to verify B is an inverse of A. Okay, so when we have two matrices, if I want to know if they're inverses of one another, all I have to do is multiply them together. Once I multiply them together, if I get the identity, then I can say A and B are inverses. Okay, so let's look at problem number 4. For problem number 4, we're going to say second matrix edit A. That's 2 rows, 2 columns. I'm going to put in our entries 2, negative 3, 4, negative 7. Okay, so then second quit, second matrix edit. Now we're going to put the next matrix in matrix B, another 2 by 2. So we have 7 halves, negative 3 halves, 2, and negative 1. Okay, so I'm going to hit quit to get back to the home screen. I'm going to do a quick check. Did I put in the entries to each of the matrices correctly? That's what I want to check. Okay, so here's matrix A. Looks good. Everything matches like what I want. Second matrix B. Looks good. Matches what I want. So now I'm going to take matrix A and I'm going to multiply that by matrix B. If they're inverses, I should get I2, a 2 by 2 identity. There it is. It doesn't matter if I take A times B or if I take B times A. I still get I2. Okay, so let's go ahead and state. Here we have I2, here we have I2. It doesn't matter the order that I multiply these, I still get the identity. So we're going to say because we get the identity, because our answer is the identity, A and B are inverses. Okay, so let's try this next one. We want to show or verify that they're inverses. The only way that they're inverses is if I multiply them together and get the identity, then they're inverses. Okay, so here we have a 3 by 3 matrix. We'll put in our entries. Second matrix edit. I'm going to put in B. B is also a 3 by 3. Oops, not 33. Yikes. 3. 3 by 3. Much better. Okay, so we've got 9, negative 10, negative 8, negative 12, 14, 11, negative 1/2, 1/2, 1/2. Okay, so I have that concluded. We'll clear out that old stuff. I'm going to make sure that I put in everything correctly. Okay, so that looks like matrix A. Good. Let's check matrix B. That looks good. That's matrix B. No, it's not. I notice that we have a negative 12 here, so I need to edit matrix B. This entry here should be a negative 1 divided by 2. Okay, so let's check. Okay, so matrix A was good. Now we want to check to see that now matrix B is good. So we've got all our entries there. Now A and B look good. So let's take A times B. If these are inverses, we should get the identity. We get the identity, so these are inverse functions. It doesn't matter if we take A times B or if we take B times A. Either way, we get I3, and so we know these are inverse functions. Okay, A times B, we get the identity. B times A, we get the identity. So we can say, yes, these two matrices are inverses of one another.